Determining if an electrical service is undersized involves understanding the National Electrical Code, or NEC, requirements and calculating the total electrical load. For a mobile home, the NEC mandates a minimum service amperage of 100 amps. However, this isn't always sufficient. The NEC stipulates that if the calculated load surpasses this minimum, the service amperage must be increased by 125%. In the situation described, the calculated load is 127.3 amps, exceeding the 100 amp minimum. Consequently, the service amperage should be 125 amps to comply with the NEC. It's crucial to have a service amperage capable of handling the maximum potential load, regardless of whether all appliances are used simultaneously. An undersized service can lead to electrical system overloads and potential fire hazards. It is recommended that a qualified electrician upgrades the service to 125 amps to ensure safety and code compliance. In addition, it is important to investigate whether any electrical modifications, such as adding an electric oven to replace a gas range, were performed without the necessary permits and inspections. Such alterations can pose safety risks. Therefore, a comprehensive inspection of the entire electrical system by a qualified electrician is highly recommended to guarantee its safety and adherence to regulations. Electrical service sizing involves several steps and considerations outlined in the NEC. Understanding these principles is crucial for ensuring a safe and reliable electrical system. Firstly, the NEC provides methods for calculating the total connected load. This involves adding up the amperage requirements of all the electrical devices and appliances that will be connected to the system. Secondly, demand factors are applied to the connected load. Demand factors account for the fact that not all appliances will be used simultaneously. These factors reduce the calculated load to a more realistic estimate of the actual load that the service will need to handle. Thirdly, the NEC provides minimum service amperage requirements based on the size and type of dwelling. For mobile homes, the minimum service amperage is typically 100 amps. Fourthly, if the calculated load, after applying demand factors, exceeds the minimum service amperage, the service amperage must be increased by 125%. This ensures that the service has sufficient capacity to handle the maximum possible load. It's also necessary to check the conductor ampacity. The conductors feeding the main disconnect and the branch circuits must be sized appropriately to carry the calculated load. NEC Table 310.15 provides ampacity ratings for different conductor sizes and insulation types. If the conductors are undersized, they can overheat and cause a fire. Next up is overcurrent protection, such as circuit breakers or fuses, which must be sized appropriately to protect the conductors and equipment. The overcurrent protection should not exceed the ampacity of the conductors it protects. Also, grounding is essential for electrical safety. The grounding system must be properly installed and maintained to provide a path for fault current to return to the source. This helps to prevent electrical shock hazards. Bonding refers to connecting all metal parts of the electrical system together to create a low impedance path for fault current. This also helps to prevent electrical shock hazards. Electrical panels, including the main disconnect and branch circuit panels, must be properly sized and installed. The panels must have sufficient capacity to accommodate all of the circuits that are needed. Also, wiring methods must comply with the NEC. The NEC specifies the types of wiring methods that are permitted for different applications. The wiring must be properly installed and supported to prevent damage. In addition to the NEC requirements, local codes and regulations may also apply. It is important to check with the local building department to determine what codes and regulations are in effect. If any electrical work is performed, it is important to obtain the necessary permits and inspections. This ensures that the work is done safely and in accordance with the codes. Electrical safety is paramount. Working with electricity can be dangerous, so it is important to take precautions to protect yourself from electrical shock. Always turn off the power before working on any electrical equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician. To further elaborate on the process of electrical load calculation and service sizing, consider the specific appliances and equipment found in a typical mobile home. Firstly, lighting is a significant component of the electrical load. To calculate the lighting load, determine the wattage of all the light fixtures in the mobile home. The NEC provides guidelines for calculating lighting loads based on the square footage of the dwelling. Secondly, small appliances such as toasters, coffee makers, and blenders contribute to the overall load. The NEC requires that each small appliance circuit be rated at 20 amps, which corresponds to 2400 volt amps at 120 volts. Thirdly, major appliances like refrigerators, washing machines, and dryers consume a substantial amount of power. The nameplate rating on each appliance indicates its power consumption in watts or volt amps. Fourthly, electric heating and cooling systems such as air conditioners and electric furnaces are among the largest electrical loads in a home. The power consumption of these systems can vary depending on their size and efficiency. Fifthly, electric water heaters also contribute significantly to the electrical load. The nameplate rating on the water heater indicates its power consumption in watts or volt amps. Sixthly, electric ranges and ovens are high-demand appliances. The NEC provides specific rules for calculating the load of electric ranges and ovens based on their nameplate rating. Seventhly, other electrical devices such as televisions, computers, and entertainment systems also contribute to the overall load. The power consumption of these devices can be determined by checking their nameplate ratings. Once the connected load has been determined for all the electrical devices and appliances, demand factors can be applied. Demand factors are multipliers that reduce the calculated load to account for the fact that not all devices will be used simultaneously. The NEC provides demand factors for various types of loads such as lighting, small appliances, and major appliances. After applying demand factors, the total calculated load is compared to the minimum service amperage requirement for the mobile home. If the calculated load exceeds the minimum service amperage, the service amperage must be increased by 125%. This ensures that the service has sufficient capacity to handle the maximum possible load. It's also important to consider future expansion. If there are plans to add more electrical devices or appliances in the future, the service amperage should be sized accordingly. This will avoid the need to upgrade the service later. To illustrate the calculation process, let's consider a hypothetical example of a mobile home. The mobile home has a total lighting load of 1500 volt amps, small appliance circuits totaling 4800 volt amps, a refrigerator rated at 800 volt amps, a washing machine rated at 1200 volt amps, a dryer rated at 5000 volt amps, an air conditioner rated at 3000 volt amps, an electric water heater rated at 4000 volt amps, and an electric range rated at 8000 volt amps. Firstly, the total connected load is the sum of all these loads, which equals 28,300 volt amps. Secondly, demand factors are applied to the lighting and small appliance loads. The NEC allows a demand factor of 100% for the first 3000 volt amps of lighting and small appliance load, and a demand factor of 35% for the remaining load. In this case, the demand factor for the lighting and small appliance load is calculated as follows. 3000 volt amps times 100% equals 3000 volt amps. 4800 volt amps plus 1500 volt amps minus 3000 volt amps equals 3300 volt amps. 3300 volt amps times 35% equals 1155 volt amps. The total lighting and small appliance load after applying demand factors is 3000 volt amps plus 1155 volt amps, which equals 4155 volt amps. Thirdly, the demand factors for the major appliances are applied. The NEC allows a demand factor of 100% for the largest appliance and a demand factor of 75% for the remaining appliances. In this case, the largest appliance is the electric range rated at 8000 volt amps. The demand factor for the major appliances is calculated as follows. 8000 volt amps times 100% equals 8000 volt amps. 800 volt amps plus 1200 volt amps plus 5000 volt amps plus 3000 volt amps plus 4000 volt amps equals 14,000 volt amps. 14,000 volt amps times 75% equals 10,500 volt amps. The total major appliance load after applying demand factors is 8,000 volt amps plus 10,500 volt amps, which equals 18,500 volt amps. Fourthly, the total calculated load is the sum of the lighting and small appliance load and the major appliance load, which equals 4,155 volt amps plus 18,500 volt amps, equaling 22,655 volt amps. Fifthly, the total calculated load in amps is the total calculated load in volt amps divided by the voltage. Assuming a voltage of 240 volts, the total calculated load is 22,655 volt amps divided by 240 volts, which equals 94.4 amps. Sixthly, since the calculated load of 94.4 amps is less than the minimum service amperage of 100 amps, the service amperage does not need to be increased. However, it is important to note that this calculation is just an example. The actual load calculation for a mobile home may vary depending on the specific appliances and equipment that are installed. It is always best to consult with a qualified electrician to determine the appropriate service amperage for a mobile home. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or concerns. Ignoring potential hazards or attempting electrical work without proper knowledge and training can lead to serious injury, property damage, or even death. A qualified electrician has the expertise and experience to safely and effectively address electrical issues, ensuring the safety and compliance of the electrical system. They can assess the specific needs of the home, perform accurate load calculations, and recommend the appropriate service size and wiring configurations. They can also identify potential safety hazards and provide solutions to mitigate them. Engaging a qualified electrician is an investment in the safety and well-being of the occupants of the home. It provides peace of mind knowing that the electrical system is properly installed, maintained, and protected against potential hazards. Moreover, it helps to ensure compliance with local codes and regulations, avoiding potential fines and legal issues. When selecting an electrician, it's important to choose one who is licensed, insured, and experienced in residential electrical work. Check their credentials, read reviews, and ask for references to ensure they are qualified and reliable. A reputable electrician will provide a clear and detailed estimate of the work to be performed, and they will be able to answer any questions or concerns you may have. They will also be knowledgeable about the latest electrical codes and safety standards, ensuring that the work is done in accordance with best practices. In addition to service sizing and load calculations, a qualified electrician can also assist with other electrical services, such as wiring upgrades, panel replacements, lighting installations, and surge protection. They can also troubleshoot electrical problems such as flickering lights, faulty outlets, and circuit breaker tripping. By entrusting electrical work to a qualified electrician, homeowners can ensure the safety, reliability, and efficiency of their electrical systems. They can also protect themselves and their families from the potential hazards of electricity. Therefore, it is always recommended to consult with a qualified electrician for any electrical needs, no matter how small or simple they may seem. Their expertise and experience are invaluable in ensuring the safety and proper functioning of the electrical system. The importance of electrical safety cannot be overstated. Electricity is a powerful force that can cause serious injury or death if not handled properly. Always take precautions when working with electricity and never attempt any electrical work that you are not qualified to perform. Some basic electrical safety tips include always turning off the power before working on any electrical equipment, using insulated tools, avoiding contact with water while working with electricity, and never overloading electrical circuits. It is also important to have a properly installed and maintained grounding system to protect against electrical shock hazards. In addition, surge protection devices can help to protect sensitive electronic equipment from power surges caused by lightning or other electrical disturbances. By following these safety tips and entrusting electrical work to qualified professionals, homeowners can minimize the risks associated with electricity and ensure the safety of their homes and families. Electrical safety is a shared responsibility, and it is up to each individual to take precautions and be aware of the potential hazards. By working together, we can create a safer environment for everyone. In conclusion, determining whether an electrical service is undersized requires a thorough understanding of the NEC requirements, accurate load calculations, and consideration of future expansion plans. Consulting with a qualified electrician is essential to ensure the safety, reliability, and compliance of the electrical system. By following these guidelines, homeowners can protect themselves and their families from the potential hazards of electricity and enjoy the benefits of a safe and efficient electrical system.